We're going to take about an hour, talk a little bit about Red 5 Studios' journey on the platform, on AWS. To start off, I'm Jeff-Berube. I'm the Director of Technical Operations. I manage the team who handles all of the platform. So the minute it leaves development's hands, we shepherd it out to the public. So just real quickly, we're going to be looking at just what FireFall is. It's one slide. I'm not here to sell FireFall to anybody here. And actually, there's only maybe one marketing bullet point on that slide. We're going to talk about why we would actually build stuff in the cloud. Some of the goals that I set out with when I first started. The evolution, which is kind of the meat of the presentation, from where we started to what we're doing today, and what decisions we made along the way. And if we still have time, some of the tools for success, third-party stuff, first-party stuff. So to start off, what is FireFall? There's that one bullet point. So we're a free-to-play, cooperative, open-world shooter. It is pretty much what it sounds like. It's all cooperative right now. We do have PvP aspects that we've actually turned off to actually focus on the cooperative aspect. It's a shardless world, and we'll talk about that a little bit later, about what we were trying to accomplish. And here's the important thing, and this is extremely important about making it actually work on the platform, is in our case, we use instance-based maps. You have both persistent maps, maps that actually live all the time, and those are your open world maps. And then also transient map types, which are 5-man maps, 15-man maps, 30-man maps, stuff that will take 10 minutes to 40 minutes. And once that experience is done, we shut them down. So looking at why does the cloud make sense? The first thing is players are unpredictable. You have a lot of forecasts. People try to forecast how many players are going to show up. And unfortunately, more often than not, they're wrong. Either you have too many players, and if you're in a traditional data center, you buy a bunch of hardware. You have too many players, and everybody has a bad experience because you can't get online. And especially in a free-to-play game, you don't get a second chance. If they can't get online that first day, there's no investment. They haven't paid $60 for a box, so they're not coming back. The other case is you spend a ton of money up front, huge capital investment, and then nobody shows up. From a player perspective, that's not too bad, because other than your world may be a little empty, if you do intelligent things about placing players, it's not too bad, but at least they can all play. But you have the lost opportunity with that cash because you got all this hardware, and you can't get rid of it, really. Even if you've never used it, the minute it comes out of the box, it's used. Nobody wants it. Now, on the other hand, your developers are just as unpredictable. Anytime you're doing active development, there are risks. From patch to patch, performance can vary wildly. Sometimes developers are working on stuff that you haven't heard about yet. So it's the day of the patch, and like, oh yeah, we got to put these new services out. And if you're in the business of buying hardware, you're talking about weeks, if not months. There we go. And trying to catch up when you're way behind the curve, it's like, oh, we have to build all this hardware. It's going to be weeks, if not months, to get that, if you have room at all. And so the thing to remember is MMOs are always in active development. Just because you've launched, nothing stops. It's not like a packaged product where you put it in a box, maybe 2, 3 patches, 5 patches over the next 6 months. You're always putting out content. And in the free-to-play space, we're talking about weekly content updates. Now, another reason is that the player behavior, because you've got to be close to your player, opens up opportunity for savings. Now, this is actually one of our real player graphs. I don't really want to talk about this. That's, for some reason, we had an outage. I chose the wrong day to pull a graph. So this is actually 36 hours. Now, if we just put an overlay and assume we can run at our maximum population with 6 servers, In a data center, you'd have to buy 6 servers. Actually, you'd have to buy a lot more than 6 servers, but 6 servers. During these hours, they're totally idle. Now, if you're in a sharded environment, a realm-based environment, unfortunately, players are on all those servers all the time. So if you can turn stuff off during those hours, all these hours, and probably here's the difference. Like, if you planned appropriately, you could probably get away without running servers for that hour. That's actually 2 hours in this graph, but you could probably not have servers here. You probably don't need servers there. It's right on the border. You shouldn't be filling them above 60, 80% at maximum anyways. So 35 to 37.5% savings by just turning those servers off after hours. You can use auto-scaling to do this if you built the metrics in. We don't actually do that. We've written some stuff in-house for that. And this is specifically on just the game server side. You got the same thing across whatever your architecture is. Now, when I came to Red 5 Studios, which was the beginning of 2011, I'd actually come off of another project, and I've worked on MMOs before. So there's some specific goals that I had coming to this environment. And it breaks down into 2 different areas. So the first is, how do we make the site management better? And we'll talk about these in detail. Those are expansion, scalability, disaster recovery, self-healing. And the other side of it is, how can we make the platform make the player experience better? Because ultimately, that's the only thing that matters. All this other stuff that's just the operations team's headaches. And if we do everything on the left-hand side, you work with a smaller team. But if you fail to do these things on the right-hand side, you don't need a team at all. So deployment and recovery. And I talked about this a little bit. So quick regional expansion. It's normally a multi-month process. You've got to get contracts with the colos once you find somebody. You've got to talk to different salespeople, find out what the right solution for their hardware is, get it ordered, then when it finally shows up, you got to install it. I spent 4 months out in China with my last deployment. 4 months is a long time to be in China. Love the country, but 4 months is a long time. And I've got kids and family and what have you. Now, and actually it's slower now than it used to be, we can actually bring up an entire region. So as an example, we're looking at moving into Tokyo. It's about a week. And I've actually been talking to people this week to find ways to make that faster. We used to have it down to 2 days without ever leaving the office. On-demand scalability is super important. And this is what we talked about a little bit before. Sometimes you'll deploy something that doesn't work quite the way they told you it was going to work. Scale is an interesting thing. And especially in gaming, where it's really difficult to emulate what a player is going to do. The complex interactions between the client and the server. So you can try to do load testing, and you make your best effort, but half the time, once you finally get it out there, it works entirely different. So you may need to have 2, 3, 4 times the amount of hardware you originally estimated you're going to need from your load testing in order to just make it work. And so you've got a choice: add more hardware or be offline. The nice thing is in the cloud, we can do it. We've actually deployed things that have 5 servers behind them. Find out there's some sort of performance issue, and by the time you're finished, you have 70 servers powering one feature. Now, you don't want to run like that forever. It costs money. But the nice thing is once you actually work with development, figure out what's going to take, iterate rapidly to fix those problems, you bring those things back in line. Disaster recovery is another issue. Traditionally, you set up a site that's got an entire copy of your hardware somewhere in the world. You want to keep it warm, but you don't want players on it. It's a lot of work to keep that stuff up to date. There's nobody on it. You've got a lot of money sunk into a site that nobody will ever see if everything works out. So you end up with hardware that's just rotting, stuff that's out of date. Ideally, you can automate that. And what we've actually done, we'll talk about a little bit later, is all of our sites are live. All of our data is everywhere. If something goes down, it's fine. The player gets bumped. They log back in. They never even know. They're connected to another site. Maybe their latency is a little bit higher, but they can deal with it. Now, automating that, I have to be careful. The worst thing you want is you've automated everything, you're like, oh, don't worry about it. And then everything's corrupted, and now you've got a multi-day outage, when if you'd done it by hand like we do now, it may be an hour. I think the last time we did it, user error. Somebody deleted all of our masters for the databases. It's easy through the console. It was about 45 minutes. And we learned a lot, so it should be faster next time. Self-healing, I don't really have any bullet points for this. The big thing is I don't want to wake up in the middle of the night because something's broken, something's not performant. And the systems we've built, and you can do the same thing with auto-scaling, will identify the resources that are actually performing poorly and remove them, or add additional capacity. So let the underperformance stuff just run. It's fine, as long as you got capacity elsewhere. Now, from the platform side, it's really important that when the player wants to play, things are actually available. Traditionally, and people have gotten better at it, but traditionally you're talking about once a week, once a month. You tell everybody, everything's down. Come back in 4 hours. Come back in 8 hours. That really sucks. People don't have a lot of time. And especially in the case where you're a free-to-play game like we are, that's costing you money. If it's a subscription-based game, it sucks for the player, but it doesn't cost you anything. Every minute of downtime, be it planned or unplanned, costs us money. So it's extremely important. We actually do blue-green deployments. We bring up not the entire stack, but the entire game stack every single time. We do it a day in advance. We let it run overnight. We're running a minimal stack. QA has plenty of time to look at it. They've got their run list. They can run through as many times as they want. Once it's ready to go, maybe it doesn't make it the first day. Maybe we find a critical bug. The player never knows. Once it's ready to go, they hit a button, people start moving over to the new version. We leave the old version up for 4 hours, 8 hours, 12 hours. Obviously, that costs us money. But people will naturally, as the churn throughout the day goes on, they'll move over naturally. It gets to a certain point, people may be just idling, running bots, kill those servers. Now, here's something to remember is downtime, you should still plan for some downtime. Yes, you can do everything online if you really wanted to, and it'll take a lot of time to get it right. And even worse, some things you're going to do may not be entirely safe. So part of the stuff that I worked with the development team, because hearing, oh, we're never taking anything down, was a major freak out. You can't do that. Well, it's a process. You work with them, you figure out what's safe, what's not safe. And I think since we launched the closed beta, we've taken 4 planned downtimes, and that's almost 2 years. And some of them have been really long. Like when we moved to VPC, it was a very long downtime. And we'll talk about that a little bit. Now, this is a personal pet peeve of mine. And we're talking about shardless versus sharded or realmed-based deployments. Traditionally, those companies, they see it as a profit center. Some companies make a lot of money from you buying character transfers. So you're playing with a bunch of friends, some stop playing. A bunch of your friends are playing somewhere else now. Now it's $25 to move your character. Every single time you want to do it. So what I wanted to see is our character data, our players' character data anywhere in the world. And what we've actually built is you can be playing on the East Coast. You're playing along, all your friends log off. But you've got other friends who have logged in or logged into Europe. You join a group, join leader, your character gets moved over there automatically, all of your data's there. And this actually plays back to allowing us to do disaster recovery. Because if your character's up to date anywhere in the world, if we lose an entire site, it's okay. You may lose, I think our replication runs around 6 to 10 seconds behind. So worst case, you're going to lose 6 to 10 seconds of data. Most players will never even notice, which is actually kind of good. If you lost 6 to 10 seconds of your bank transactions, that'd be a different deal. But I don't work in the banking industry. Now, the other thing is that something to remember is we prefer the closest healthy region. So in the case where we've got a region that's underperforming or has having an issue, we turn it off. and you'll be moved to the next best region for your play. There's going to be latency implications to that. We've actually built a game that's relatively latency tolerant, about 200 milliseconds. We actually drag the Southeast Asia all the way to the West Coast, and it's okay. It's not ideal, but it's okay. So, looking at how we started, the steps we took to get to where we are. The beginning, March 2011, we're in US West 1. US West 2 didn't exist yet. And there was a good reason we were in West 1. We didn't have the best experience in East 1. And so that's where I built everything. One box, built by hand, EC2, that's it. Honestly, I didn't think it was going to work. Everybody tells you, oh, you can't build an MMO in the cloud, especially a shooter. There's going to be latency, and there's a virtualization, and your whole noisy neighbor thing. And I was like, well, what do I have to lose? We're not live yet. So I built it. One box, built by hand, no AI. They call it the nothing map or the checkerboard map if you ever play the game. There's nothing there. We're just me and the VP of product development shooting at each other. And you couldn't do damage to each other. We had no PvP yet either. But I was like, this might actually work. Which was good, too, because it took me so long to get there. We didn't have time to buy hardware anyways. Don't tell anybody. So October of that same year, we actually launched the alpha. Now, it's friends and family, really small group. Here's the thing is, we were running servers around the clock. We only let them in for 4 hours twice a week. But we wanted to make sure we understood what it was going to be like to actually manage those servers around the clock. We did a bunch of stuff in between having one box and alpha. So this is in EC2 Classic. We've added S3, elastic load balancing, simple queue service. Now, SQS is kind of interesting. We don't actually use that for the game. That's used for processing crash dumps. It takes a lot of time, and it's not time sensitive. So put in a queue, we got a background process that does it. So the big thing is to understand what parts of the infrastructure need to talk to the player, what parts don't. And we actually built a multi-tier infrastructure where you have some parts of it that are actually they're game servers, C++ stuff. Behind that, we actually built a web tier. And that's specifically so that the game servers don't talk to the databases. We wanted to be flexible in what we actually deploy. And so it doesn't always make sense to have a relational database behind this, which is what traditionally you would build. But anytime you want to change something, now you got to talk to the developers. Oh, we got to add caching. We've got to add a NoSQL solution. And there's a lot of code changes. They build a system that takes what the game talks, turns it into JSON, and then we send it to a bunch of web servers. We can scale web servers relatively easily. Scaling databases kind of sucks. And I've done that enough times not to do that again. And then that development team, our backend team, can actually do whatever they need to do. They got to have caching, they add caching. And that's actually continuous deployment. They push multiple times a day, many, many times a week, all the way out to production. Which is kind of cool because whatever we build back there, we can actually hotfix really, really fast. So this is the original one. You notice all-in-one AZ. Not the best practice for what we're trying to do, but it's alpha, running a couple times a week. Closed beta was April of the following year, April 2012. We actually announced at PAX East of that year. Said, hey, if you came to the show, you're in closed beta. Because we were actually now live all the time, we wanted to make sure that we did follow some of the best practices. Multiple AZ. Now, it's kind of interesting. At that point, we're still in one site, still in West 1. We'd been running MySQL databases ourselves. But it didn't really make sense. RDS was really good. They handled all of our backups and what have you. So we're like, yeah, let's just strip out our databases. We just ported them all, ran them on RDS. We actually we changed the way some of the game server worked. We found that we were sending a lot of traffic between different services. So we consolidated some stuff. So we weren't as safe as we once were with only half the game being accessible to the public. We had to put stuff on the same servers. It just kept me up at night. It was not a bad deal. And so, this gives you an idea. Definitely, you're not going to be able to duplicate our environment from this, but it gives you an idea how we group stuff. All security groups, firewalls on the individual servers, everything using Chef. We don't ever build anything by hand, ever, in production. Actually, even dev test, we don't actually build anything by hand. Here, we actually started to need some caching. Our user numbers were going up. And so we implemented some small amounts of caching. Caching too early leads to issues later where you're dependent on the cache to be able to run. So we hold it back to the very, very end. Now, Gamescom, which is in August 2012, you'll see one of these is red now. That's actually Europe. And actually, it was interesting. This is the first time I missed a date. So for Gamescom 2012, we should have been multi-site. In order to accomplish that, though, obviously there's a limit to what RDS does. It worked at the time in a single site. But if you're running locations in 2 different continents, and you need your data to be everywhere, you need to do replication. And that wasn't an option for us. So unfortunately, we had to pull all those RDS instances out. And this is also the first time we moved to VPC. There was a significant learning curve, which that and replication led to us missing that date. VPC has a lot of really cool stuff in it. Internal ELBs. Being able to determine what your subnets are, what your IP blocks are. And you'll see, and it may not be terribly obvious, so those blue lines, and in order to do replication, we set up a full mesh VPN across all of our locations. So now you know what your IP blocks are. You're not worrying about trying to manage what your public IPs are. They come up randomly out of blocks that are assigned to EC2. But getting to VPC was a challenge. There's a lot of differences. The other thing is, you'll notice, is that we had to make a choice. Subnets don't span AZs. So looking at it, we're like, OK, we can create 2 subnets for every single part of the service and then try to route everything appropriately. But because we're actually able to fail over to any site and we load balance across all of our sites globally, it made more sense just to build it all in one AZ, which not best practice, but it worked. So we also, between these 2 dates, actually added CloudFront. We were working with another provider, had some performance issues, and we worked with them for a long time to try to figure it out, and it just didn't work. The nice thing is without a contract, we just switched over to CloudFront, paying public rates, and things just worked. And in the one case, we actually had some weird routing issues. We contacted the team. They were fantastic. We got in touch with the engineers. We provided them logs of everything. We log a lot of stuff. We provided them all the logs for these customers that were complaining about poor download speeds or errors, and those problems just disappeared, which we weren't getting previously. So this was interesting. The other thing we did, because we had a full VPN mesh, is we moved to, and it's on the far left there, moved to a DMZ site, where we started building stuff that originally we would actually have to spread all over the place and try to coordinate it. This allows us to take different aspects of the service and put it in one place. In this case, it's just app boxes or task boxes. So they run cron jobs that do different things in the data. But thankfully, we just run it in one place without trying to have to coordinate which site's running data on what. Because remember, all of our data is everywhere. So if you run it on the East Coast, it's going to affect data for everybody unless you write all this crazy stuff. And the thing is because everything is automatically built, and you're not really watching the performance or the status of any individual box, if you lose the box that's doing it on the East Coast, you may not notice right away until somebody's like, hey, my leaderboards didn't update. And that's not great either. So we put it in one place, we know that's running there, and we can keep a much better eye on it because it's no longer part of the main infrastructure. Because that's the other thing to remember is, in talking about disaster recovery, everything is everywhere. The website is in every single site. All your player data is in every single site. Any site can act as the master for everything. If we lost everything and had one site left, things would still run. So we went to open beta middle of the summer. West 2, East 1, EU. So it's interesting. So we had to move away from RDS so we can do replication. Now, in order to run multiple sites like that, and because of the way we were originally architected, we were running globally replicated rings. So there's a master at every single site using GTID. We'd actually prototyped with 5.6.5. Things worked great. It went GA. Went to 5.6.10. Not so great. There was a lot of bugs that we didn't expect. And so our DBAs were being run ragged, keeping everything running. Because you lose a site, we'd fail everybody over to somewhere else, rebuild all those servers, add them back to the ring, let everybody move naturally back to the site. And we did that over and over and over again. It's a lot of operations time, but it actually worked. And it was kind of cool because all of your rates were really, really fast. Not maintainable long term. But other than that, like, things were about the same. We were bigger. Some of the services were actually more mature. The big thing, and actually was a big game changer for us, was Elasticsearch. So we put that in a central site. So we log a lot of stuff. And also, we added MapReduce, because what we do is the game produces logs, all of your chat gets logged. We funnel that all into Elasticsearch so that if you've got a customer service issue, they can pull up things immediately on everything you're doing. If you're like, oh, this person's harassing me, or I got this drop, but it didn't show up in my inventory. I bought something, and for some reason, I don't have it. They can see that milliseconds. They do searches. We keep it for about 30 days, then we purge it. Additional data that will actually go to Elastic MapReduce, so we can do more business intelligence stuff, analytics type stuff. But we didn't want to build our own cluster. Elastic MapReduce is really, really good for that. And we're still working on that. That's actually in progress. Since that time, and we're almost to the end with that, since that time, today, we've been prototyping Brazil, prototyping Tokyo. None of those are on the roadmap to be released, but we wanted to make sure we could do it when we wanted to get there. We've consolidated a lot of stuff. There's actually been a big thing recently. So our bills were getting large-ish. And so I started to hear about it. Hey, why is this so expensive? I'm like, it's really cool and clean. Everything is perfect, just the way it should be. That's not always the right answer. And so what you'll see is that we consolidated all of our load balancers. We had 56 load balancers, so 28 pairs. Every backend service was a perfect stack: load balancers, application servers, database servers. It was really nice. You can get really good metrics about how things are performing. Not the most cost-effective solution. So first thing we did is we consolidated those. So now instead of 56 boxes, 28 pairs, we're running an inside pair and an outside pair. The nice thing is using Chef, and with searches and a bunch of Chefy magic, service comes up, boxes come up, they get added automatically. We don't think about it, we don't worry about it. Add app servers, they get added to the load balancer. Take app servers out, or they start to misbehave, they get removed. We also did the same thing with the database servers, and that's more of a task. And actually, one of our 4 downtimes, planned downtimes, we're moving a lot of data around. We were running almost 100 database servers per site, no EBS. Everything was instance-backed. One of the big issues we had was an EBS-based outage, and super gun shy. So we're like, we're not running with EBS. So everything had to be kept in memory all the time. So no matter what you were doing, every site got 3 database servers for that service. To about 100 per site. All different sizes, from smalls up to 2XLs, depending on the service, which is kind of cool because you move them around based on exactly how much work they're doing. In this case, though, we've brought it down to 5 different clusters, kind of around the features that they were actually responsible for. Everything else pretty much stayed the same, different stacks. Actually, and we'll talk about it in a second, to take advantage of that savings, Cartographer spins a lot of this stuff up. We'll talk about Cartographer in just a minute. It's quiet, the way I like it. Things just run. And if there's spikes, boxes come up. We're actually working on automating some more stuff. So, we run without a knock. Things just take care of themselves overnight. If they don't, then we hear about it. But very, very few emergencies. And some of that is about because of the tools we use. Some of it's just how things are built. So talking about tools. So we got third-party tools, internal tools. There was a third section on this that I had to take out, unfortunately. And that's stuff that we're going to open source. It's all chef-based stuff around friendly naming and DNS. So we actually run internal DNS servers that do dynamic updates whenever a host comes up, so you have friendly names. It's much easier to go to web keys than it is some crazy instance name. The OpenVPN, we use OpenVPN for our VPN mesh. So we've got cookbooks that take care of all that. And Keep Alive, D, which we use for failover. When we moved away from ELBs, one of the big things is that would handle failover. And without VIPs, which you can get with VPC, one of the other reasons we moved to VPC, it wasn't easy to handle. So all that stuff is all does failover automatically now. So obviously, one of the biggest things that makes it possible for us to do this is Chef. Nothing is changed in production. You don't build anything in production from scratch, not even in dev test, not in pub test. Even in dev test, if a box is built by hand, it's stripped down and rebuilt with Chef. It's only built by hand to figure out what we have to do. And so it doesn't last very long at all. The next 3, Collect D, Achinga, Graphite, that's how we handle metrics collection. Collect D, super, super light. We pull metrics across the entire environment every 10 seconds. Achinga actually has a plugin for Collect D. So we don't actually, Achinga doesn't, or Nagios or Achinga doesn't reach into your servers at all. It has data locally, it reads that data, makes decisions. And then Graphite allows anybody in the organization to graph whatever they want. The nice thing is the way it's set up is, as long as they're using common data types, anybody can instrument anything. So even if they only need it for a few days to see what's going on, they can add in metrics, it'll show up as graphs. Make their own dashboards, and away they go. They don't have to go to us to say, hey, we need you to graph such and such. They just get access to it. Graylog 2, so log aggregation so the developers can look at it. HA proxy, we use everywhere. We were using HA proxy before we went to ELBs. We're using HA proxy now. And to be honest, the big reason we moved away from ELBs internally is we just didn't have the visibility we needed. Being able to see what the timing is on every single route of your application is super critical. You sit there watching, looking for things that are outliers. Using Collect D, aggregating what the percentage of 503s you're getting, 404s. And then you can report that stuff back. Keep Alive D, we're using for automated or for failover. There's actually been some really cool work done by some people in the community, including some stuff that was done by the guy, I can't remember his name right now, the guy who wrote HA Proxy. Made some changes that got accepted mainline, which is fantastic. Elasticsearch, I can't say enough good things about Elasticsearch. It's fantastic. I know there's compliments. I know there's Cloud Search. I don't know what it does. I don't know if it's comparable. Some of the stuff we've built can actually obviously be replaced by services that Amazon and AWS has built. Unfortunately, sometimes we just find out after we've already started building it that it's available, or, oh, it'll be out in 2 weeks. Well, I need it now. And we've already spent 6 weeks on it, so we might as well just deploy that. And we got a bunch of other stuff in the environment, Blue Pill, and RabbitMQ. Could we use SQS there? Now, we also use third-party services. In order for us to do our global failover, now I know that Route 53 has some things that are comparable to what we do with Dyn for our global load balancing and DNS failover. They've been a pleasure to work with. Part of the reason we started using them is that those Route 53 features weren't available yet, and I had to launch. And we've got some stuff there. We're looking at Route 53, but it's hard to say if we'll move. It works right now. PagerDuty. Without a knock, invaluable. I don't wake up when people send me emails or text me, and nobody on the team does either. If Nagios or Chinga sends an automated alert, they get a phone call. The computer on the other end says, hey, there's an issue. Are you going to go ahead and work on this? We handle all of our escalation through there. We handle our on-call schedules through there. Very attractively priced. Without a knock, I wouldn't even, everywhere I go, if we don't have a knock, I'm putting PagerDuty in. I really enjoy the service. Pingdom we've actually just started using recently, and their transaction monitoring is really, really cool. And you could build this yourself if you really want to. But it will actually step through a series of web pages, as an example. Your login flow, your billing flow. It'll load a page. You tell it which tags you're looking for, if it's a div, it's a button, what to do. And it will walk through, time every single aspect of it, and then if anything fails, send an alert. Just recent, relatively new, but also fantastic. We were looking at doing it ourselves, but developer time is best served working on the game versus working on something that I can pay $30 a month or whatever it is for. And then Duo, two-factor authentication. We use it for all our VPN stuff. I know they have solutions for like end users as well if you wanted to give everybody in the community two-factor, which for MMOs is super important. You get a lot of fraud, a lot of customer support calls because somebody hacked my account. We have implemented something else, but that was our choice. We decided to put developer time on it, but they've got a solution for that too. But we use it only internally. Now, the stuff we've built ourselves. So Architect is a service we use to actually track what the infrastructure is doing. Everything in the environment heartbeats, and we run at 10-second intervals, just like Collecti does. And so in one place, we can see the state of everything going on. And we use this for a bunch of decision-making. Like, you've logged in, the site's live, where should we put you? Because we're shardless, you don't have to go back to the same server. We make a bunch of decisions about who your friends are, if you're in an army. And we've already decided what site you should be in if it's the closest one to you. Now, Architect with Oracle can actually send you to a different site if it has to. And we do when we're under capacity in a location. But it's integral to me have a view of what's happening, especially when things are coming up and going down on their own. The second thing, and this is what I was talking about earlier, about saving money by turning stuff off, is Cartographer. It has the intelligence to build new game server stacks. Now, we're doing some of the stuff, it's still early. We're doing some stuff by hand as far as not building servers, but choosing what servers start up for a base stack. After that, Cartographer takes over. The end goal is if there's a new build that QA's approved, it'll just start spinning them up. They don't have to talk to anybody. Autoscale could do it. We're using it most because we're looking at stuff going on inside the game. And we could probably instrument it, send stuff to CloudWatch. But since we're already grabbing everything with Architect already, the state of what the game's doing, how many people are on it, how it's performing, it made sense just to write our own stuff. And so it scales up and down. And it's still being tuned. This week, if you were playing, may have been rougher than others. but it's okay. Nobody knows. And then dashboards. So you get a lot of questions about what's going on in the environment. If you've got data sources you can pull from, they don't have to ask you. They can just go to the dashboards. So we've got population dashboards and economy dashboards and revenue dashboards and all sorts of stuff. What people are doing, who's being killed, how often. We track people in all the different instances in the game. And we pull a lot of stuff from Graphite. Some stuff comes out of production. We try to limit how much stuff comes out of production, but sometimes you need real-time data about what's going on right now. And if you can't get that out of Graphite, and you can't wait 24 hours, then you have to go to production to get it. We've got a lot of read slaves, so it's not too bad. Finally, we pull a bunch of stuff from the business intelligence databases. We take every one of our databases. We actually back up every single hour. Once a day, it jams all of that data onto one server. And then all sorts of reports run. People jump on there and do queries to find out what's going on in the world. Here's where I would talk about the stuff we're going to open source. We touched on it already. Hopefully, we've got a GitHub account. Hopefully, in the next couple of weeks, we'll start to get that stuff out there. So I welcome you to check that out. It's some cool stuff that's made it easy for us to operate in the cloud. And we wrote it specifically because it would have been more difficult to go without it. With our schedule, we just didn't have time to get it all done. I actually didn't put the final slides in until Friday because I was hoping we were going to have it ready. But it wasn't to be. So this is a kind of a whirlwind tour of where we came from, where we are. I appreciate y'all listening for the last 52 minutes. And if you have any questions, I'll be more than happy to answer them for you. You got a question?
Do you guys run your build servers then on AWS, like making it like that?
So right now, we don't. That actually happens internally. That's traditionally been owned by the development team. We're in progress of migrating that to our team, and at that point, we probably still won't. We have enough resources internally to do that. And the other problem is that we kick builds a lot. And so there's a lot of data. Pushing out the servers takes a little while. So this allows us to actually build over and over and over and over again. And they get that first step inside the office, so they can see the results within minutes of it actually being finished. We're mimicking some of the stuff we're doing in the cloud, and we're actually working towards that even more, so that it's consistent. But traditionally, it's significantly different. So that's why we try to push to AWS early, and then we push to, like, our public test environment, even before the public sees it, gets pushes multiple times, sometimes multiple times a day, but usually just a couple times a week. Right?
How are you handling the nodes that go trigger Chef to run on nodes that care about that?
So in some cases, and mostly like on load balance or stuff like that, actually Chef is running in Daemon Mode. But we don't run in Daemon Mode anywhere else. We don't want things to change without us knowing. Normally, we'll just replace a node. If we got a big change, we'll just replace the nodes. And that's the few cases where if we don't want to build a new stack for those type of changes, we'll just get on the box or cluster SSH out and just Chef client everything that's affected. But normally, like I said, we'll actually build up new stacks if it's a big change. And if nothing has changed, we're just adding capacity, removing capacity. Daemon Mode Chef is running on like the HA proxy boxes, so they pick that up immediately. Anything else? Oh.
So for the game servers, obviously being stateful or an MMO, how do you handle the scale down case? Do you migrate users? Do you wait for them to just leave naturally? How do you handle that?
So moving players around when we actually are bringing things down, we have a nice end goal to get to, which would create an event in the world that engages people to actually move. And in our case, it'll probably be, I don't know if nobody's played the game, melding tornadoes will come around and suck people up. Right now, because developer time is being spent elsewhere, we've got a system where we can tell the server, look, you're coming down in 30 minutes. And so for a little while, like every 10 minutes, it'll say, hey, server's coming down in 10 minutes. If you type this command, it'll move you to a new server. As it gets closer, it tells them more often. And finally, at the end, it just moves them. it gives them a nice little buffer where they can finish up what they're doing, and we also give them the ability to leave early. So if you're not doing anything, right at that 30-minute mark, the first time you see it, you can just choose to teleport and then just go on playing. Some of the state stuff is a little more difficult to handle. We're actually working on that, but it seems to work relatively well, and it puts us in a place where we can actually, without having shards, just move people around as we have to. If, like example, if we had to take down an entire site, we could just turn off operator at that location, put everything in drain mode. 30 minutes later, everybody moved to another location, another region if we had to. That's it. Oh, right here.
Are there any tools you're using to manage user feedback? How they receive these types of behaviors?
We've got a really good community team. We get a lot of feedback through the forums. They watch they watch Twitter and social networks like that. We actually also have systems internally where you can /feedback, brings up a form. It goes directly to our QA team. And they'll actually make sure that it's not coming. If it's not coming, then they go ahead and they get it to the right teams for feedback. And we spend a lot of time reviewing that feedback. We've made big sweeping changes in the product, specifically because of player feedback. Sometimes too often, but we've had a couple systems we've rebuilt 3 times because we're like, oh, this should be good. No, people hate it. How about this? No, people hate that too. That's what they asked for, but they still hate it. So we end up somewhere in the middle. And part of the reason our beta has been kind of long, because we've built systems over and over again to get what the player wants to see. Because ultimately, traditional design, if you're not getting player feedback, you're building what the developer wants to see. And then you find out at the last minute that that's not what anybody wanted. It takes a little bit ego crushing if what you're like, this is awesome, and everybody hates it. But yeah.
Do you guys run dedicated database instances per service, or you shard?
So we're actually able, the nice thing is because we're able to use bigger and smaller instances, we've just been growing them. We're really not looking forward to having to shard things. Most of the time, every sharding, people are just having to rewrite the same stuff over and over again. As long as we can stay on a single instance, we will. And then probably what will happen is that, and that's actually kind of how I do my design, is you find out what the piece that breaks first is, which you reach your limit, and that's the limit for the entire site, and you just build another one. So because we can do that, if we find out that we reach the limit of a single database instance, and we don't want to shard it, which we really don't want to do, we'll just say, okay, this is as big as this site will ever get. And then we'll build another one. And we'll build another one, and we'll build another one, just keep making it wider. And then also gives you fault tolerance. If you lose an AZ right now, if we lose an AZ in East, we have to move everybody to West, or everybody to Europe, whichever's closer to them. But if we had 4 AZs in East, or 4 different VPCs, all in different AZs, then great, you lose that one, they'd move to one of the other 3. And so we're still waiting to find out what that bottleneck is. We haven't found it yet. But as soon as we do, then we'll actually cap the size of the site at that. All right.
Replication allow you to scale when there's a lot of congestion, say like in a city, you have a lot of connections, like people all in one area. So you have to chart.
So in that point, if we can't bring up more instances, if we can't bring up more game servers, because that's what we do, is we just continue to grow wide. So you put more of the new Eden instance in place, the open world instance. You just keep putting more and more. If we were to reach a point where we can't get any more, which usually is only transient, you'll see like a few minutes where you're requesting them and you can't get anything. We use kind of big instances. If that happens, what will actually happen is if there's no more capacity, through Oracle, when the request comes in, it'll say, well, there's no capacity here. You're going to go play at our sister site, which right now, because we're only building a single VPC per location, like East is the one that's the worst. If you log into East and there's no capacity there, you may go to West, you may go to Europe, depending on where the capacity is available. Latency-wise, it's okay. But yeah, so if we ever reach the capacity of a single location, then we just shuttle you to the next one. And so you'll play there. And the nice thing is the next time, if you were to log off and log back in, it'd move you back to East. And so as long as there's capacity there, you'd play. Or if you were, they moved you to West, but your friends were in East, you can actually move back when there's capacity available. That make sense?
What parts of the Chef server do you have to implement?
So the thing is that so we run, we're not running hosted chef, we got private chef, so we actually run one at each point. Right now, we're not baking any AMIs. We used to bake partial AMIs, kind of the hybrid approach where I'd pre-install like half of the stuff, and then we run the chef client on boot. So it would actually finish the configuration, especially if things have changed. So you don't have to rebuild it every single time you push out an update. So we still have a dependency. As we're scaling up or down, chef has to be up. The problem is at one point we were running over 1,000 instances. And so hosted chef is per instance cost, and that becomes cost prohibitive. And so that's why we decided to go to private chef. Unfortunately, there's no redundancy built in. That is EBS backed, so we've lost I think one. And during that window where we're alerted and we're getting on to fix it, you can't scale up any further. But the nice thing is because the way things are built, people will be shuttled to other sites. So they don't really see it. They just get capped out of their location. They'll get a little bit higher latency, but we're relatively, like I said, relatively latency tolerant. Okay, I think we're out of time. So thank you again for coming, and I'll be around for a little while if you have any questions.